Chapter 6, Users, Groups, and Permissions. This week, we're going to introduce the idea of the user and user accounts, and at the same time, look at groups of user accounts. We're going to look at the mechanisms by which we manage, create, and maintain users and groups, actually, in both Windows and under Linux. They're done differently, but they're both done for the same purpose. We're going to look at file permissions. I mean, it doesn't really make much sense to define separate users and groups of users if we don't use that to control access to different resources, which is really, the primary reason we do this. And then we're going to discuss some password management techniques and some best practices. And we're going to look at a few worst practices too and things that we shouldn't be doing. Now, not all operating systems are multi-user OSs. Most are nowadays, but that wasn't true going back in the past. Looking at our chapter from last week, getting a little carried away here. Looking at our chapter from last week, we were at the history of operating systems. Let's go back to 1981 to DOS, and even into the 90s, which the DOS-based OSs like Windows 9X. These were not multi-user OSs. They were single-user. What that meant was the OS had no concept of a different person logging in. You turn a system on, it fired up Windows, your face at a desktop, your face at the DOS command line interface, and there you go. There was one user, and that was it. Multi-user operating systems allow for more than one person to log into the system either at a time or just individually, but to maintain their own identity while they're doing so. Unix really was devised back in the late 60s to create a multi-user operating system. That was the whole point behind it. Its name, Unix, is actually a play on words, making fun of the fact that it's not a single-user operating system, it's a multi-user operating system. Being part of the Unix family, Linux is also multi-user by many of the same mechanisms. And on the Windows side, as we'll recall, Windows NT, going all the way back to Windows NT 3.51, and all the later versions since then are indeed multi-user OSs, including the desktops in front of you right now. So what is a user? We probably ought to talk about what that is, get all on the same page. Really, a user is an agent that uses the computer. So what does that mean? Well, most commonly, it's a human. That's what we tend to think of. Or we most commonly think that. Me, Glenn, I sit down and I log in as Glenn. Bob sits down, logs in as Bob. Susan sits down, logs in as Susan. That's what we tend to think of as a user. But a user can also be software. Well, what does that mean, huh? All right, here's the thing with that. Every program that runs on a system must run under the context of a user account. Which means if Bob is sitting on a Windows machine and Bob fires up Microsoft Excel, that instance of Excel is running with under Bob's user and with Bob's credentials. So let's take that to the enterprise. Let's say you have a web server running on Linux using an Apache web server. Well, the Apache service is a program. It must be fired up and run as somebody. I don't want to run it as the administrative user, because if the web server runs as the under administrative permissions, it can do anything an administrator can do. And if I've got that facing out into the public internet and somebody hacks my server and takes control of my web server, they now have administrator privileges on my server. Bad. What we would do is, in that case, we would create a very limited user account. One that has really no more permissions than it needs to simply fire up and run that one application. In fact, we'd make it so that that user can't even log in. It's just there to provide a pretext for the Apache service to run. And that's called a service account. And commonly, in that case, it's called the Apache user. You'll see a lot of service accounts on different systems. Now, users also provide protection for data and resources, and it does this because we maintain our own our own identities when we're logged in as a user. When I log into a system, I have access to my data and my user environment. When Susie logs into the same system, she has access to her data and her environment, but not necessarily to mine, unless she's an administrator or unless I've given her that permission. It allows us to segregate our data and provide a degree of security on the system. Well, to have a user account and to make it so just not anybody can log in as any other user, we have to have authentication. Now, there's two terms we're going to talk about here in this chapter today. One's authentication and the other is authorization. Authentication means proving who you say you are. Authorization is what you're allowed to do once you've proven who you say you are. All right, we'll explore that as we go through. So what do I need to authenticate? Well, traditionally, you authenticated with a username and password. My username is Glenn. My password is password1. Bad idea, by the way, but we'll see that. And I log into the system. And the original multi-user accounts use just that. And we still do, even today, right? Even Windows 8 and Windows 10 can use a username and password. But for many reasons, this can be insecure, right? Passwords can be guessed. People can make bad decisions on passwords. They can be compromised. You'd be surprised how many people take their password, write it in a Post-it note, and stick it to the bottom of their keyboards. Really bad. The worst I've seen is someone write the password on a Post-it note and stick it to the ceiling above their chair. So when they're typing in, they just lean back in their chair and look up. Also really bad. So we can look at the idea of multi-factor authentication. Having a username and password is single factor, right? Your password is that one single factor. I might also require a token. I'm not talking like a bus token. I'm talking about like an RSA fob. And this is a little gizmo that's actually synced to a server inside of your environment. And every minute it'll display a new 6 or 8-digit number, right? So when you go to log in, you have to provide your username, your password, and whatever value is on that token at that minute in time. Right? So that's two-factor authentication. Something that you know, your password, and something that you have, your token. We could also have biometrics. We could use a three-factor authentication. Or instead of using a token, just use biometrics for two-factor. We see this right now on the iPhone 5 and newer. Right? My own iPhone 5S has a fingerprint reader on the button, which it uses my fingerprint to break my screen lock. Biometrics is something about you physiologically, right? It could be a fingerprint. It could be some type of facial scan. It could be a retina scan. In a two-factor authentication mechanism with biometrics, it's something that you know, your password, and something that you are, you, right? Fingerprint or some other feature about you. In real secure environments, you could use all three. Usually in those cases, it's a PIN, 4-digit PIN, personal identification number instead of a password, on top of a token, on top of some piece of biometrics, or any mix thereof. So I used this term earlier when I mentioned regular users. What is that? Well, for our purposes, we can define our users into two broad groups. The first group are just regular unprivileged users. That's Bob, Sally, Sue. These are the users of the system. They only have access to their own resources, and they have no control over the system itself. Administrative users, well, that's what we're going to be. That's what you're going to school for. The idea there is you're in charge of the system. The administrative user can control the system and generally has access to all of the regular users' information, including their data, their files, whatnot. So obviously this comes with a great deal of trust, right? And it's not a trust that's given away lightly. So under administrative users take different forms, right? Under Windows, the default administrator is called administrator. Well, they weren't very imaginative there, but at least it's self-explanatory. If you log as an administrator, you are king or queen of that system. Linux has a type of administrator user also. It's called root. All right? So if you're the root user under Linux, you're the admin. All operating systems, well, most multi-user operating systems have have a form of this. I won't say all. There are cases where this isn't the case. For Cisco, the Cisco iOS for routers and switches, the administrative user is called enable, for example. Now, your regular user can also be an administrative user. Right? That's certainly possible. And what happens is that regular user was delegated authority from the administrator or root user. Right? And this is kind of a good practice. It's not an all or nothing thing. You might have an entry-level person, brand new to your organization, a brand new junior admin who just isn't very experienced. I probably don't want to give them the administrator password. Right? They don't have the skill sets yet. Frankly, we don't trust them. What we can do is give them very, very regulated authority, and then over time, as they get more experience, give them additional authority. So how do we set up user accounts? What really goes on here? Well, it's not really rocket science, and really the same process is the same idea as happens under Linux or Windows. It's just a different way of doing it. What you're seeing here is the GUI, the graphical user interface for creating a user on a Linux system. Now, looking at this system, it looks like it's Red Hat, if I just had to guess. There's a little user manager utility here off to the left where you have usernames. The user ID, that's actually a numerical value that defines to the system what that user is. Again, names like Glenn, Bob, Sue, that doesn't mean anything to the computer. What it really cares about is this thing right here, the user ID or UID. That has group information. We'll talk about that later, and things like shell and home directories, stuff a little beyond our scope right now. And notice there's a button right here, Add User. Right? You'd click that, and you'd bring up this little dialog here up to the right, where you bring in the username. Now, the username doesn't necessarily have to be the user's name. It's the username as logged into the system. You know, at the college, in the CSEC, my username is Glenn.Hussey. Well, I don't sign my name Glenn.Hussey, but that's my username in the system. My full name is Glenn Hussey. As you can see here. Look at the example. The user's full name is Tommy Mars. And the username here is Mars T. So the last name plus the first initial of the first name. Some cases it's first name, last initial, whatever. Right? It doesn't really matter as long as you're as long as for your organization, you pick some standard and roll with it. The other thing you do when you create a user is you assign a password. Right? This could be a known password that that's meant for new users. And in most systems, you can set it to where with the first time that user logs in, they have to change their password. Now, the GUI is pretty and everything, but on a Linux system, you're really managing that thing from the CLI, the command line interface, or as I like to call it, the cache line interface. Because if you understand that CLI, you can charge lots of cash for your services. Well, under Linux, there's a command line command called user add, right? And if you look at it here, it's got a bunch of options for user ID, for group memberships, for home folders, shells, blah, blah, blah. In its simplest form, though, user add, and from the example before, Mars T, Tommy Mars, and that adds that user as a Linux user. Under Windows, we see something very similar. Now, this is a local user account on a Windows system. This isn't a domain user. This is out of scope for us right now. But this would be adding a user on a single system. Well, same idea. Hey, there's our administrator user we talked about, right? And then some other users. FoxR, some user got added in here. And here's another user here. An ability to reset a password, an add new user button, which brings up a dialog like this here on the right. Looks a lot like the Linux one. A username, which is not necessarily the user's name. The user's full name, maybe a description of what they are, their password, and check this out. User must change password at next login. That's how you can get away with giving them a password that's a company standard, right? Something like, I'm a new user, exclamation point. That's a bad one, but it's just an example. Brand new user comes in, you go, okay, tell them to log in. Here's your temporary credential. I'm a new user, exclamation point. And with this checkbox checked, the first thing they'll be prompted to do is change their password to their own password. Now that's an important concept. We as admins, we don't want to know our users' passwords, right? It's really bogus to, if you ever get a call saying, yeah, I'm Joe from IT and I'm fixing your account and I need your username and password to get in there and fix it, it's probably a scam. And the reason is, an admin we can do what we need to do without needing that user's password, right? So, and really we don't want it. We can affect their account, but we can't log in as them. And that protects us as well as it protects them. There's another choice over here too, which is worth pointing out. Account is disabled, right? If I check that button, then that user account is still there, but that user can't get in. And that's generally what we want to do. It's really a bad idea to disable user accounts. Delete user accounts. Let's say you're an IT person at a company and you get a call at 5 o'clock in the morning, and it's the boss. And she says, hey, I need you to go out and delete Bob Thomas's user account. And you ask, why? Are they getting fired? Well, I can't tell you that, but just go ahead and delete it. Okay, they're being fired, all right? That's what's happening, really. Deleting that account is a horrible idea. Don't listen to them. What you want to do is actually go in there and disable that account. And the reason being is after Bob Thomas is gone, I might want to access their work. We might want to get in there and get to their home directory and extract files out of it. And in some cases, deleting the user deletes the home folder and their documents, all that kind of stuff. So, bad. Disabled is a good thing. Okay, so let's say you're an organization and you have 2 users. It's a mom and pop kind of place. Well, that's not going to be too hard to maintain. I think I could have one user called mom, the other user called pop, and maintain that just fine. What if I got an organization that has 500 users in it, or 1,000 users? Or like for when I worked for the state of Ohio, we had 3,000 users. That's a lot of user accounts to try to set permissions to things and try to govern them and manage things. It becomes untenable, really. This is where groups come in. Groups are just containers. And strictly speaking, they're meant to hold user accounts. So I can take 10 user accounts, let's say, that all need to do the same job, throw them in a group, and then assign permissions to that group, and it bleeds down to all of the users inside of that group. Right? Let's say I got a HR department with 15 employees, and they need access to these very sensitive HR documents out on this file server. Well, I could go out individually and give each member of HR individually permissions, and we'll see here on a later slide how that's done. Or, and this is actually a lot better, just make a group called HR, give permissions to that document to the group, and whoever I put in that group inherits the permission to do that. Now, groups can also contain other groups. It's called nested groups. And again, a little out of scope for us, but Windows operating systems make extensive use of this because there's different kinds of groups. You've got local groups and domain local groups and universal groups and all this other kind of stuff. And they can nest inside of each other. Groups are a very standard construct, and both Windows and the Unix family makes use of them. So permissions. I mean, the whole point of doing users and groups and all that is to control access to resources. And that's what this is through the idea of permissions. So every document on your server, every file, every directory has properties assigned to it. And within those properties, look, here's a Windows example here off to the right, you have security settings. And that controls who is allowed to access or what they're allowed to do with that document if they're allowed to access it. So key point, permissions may be assigned to users, groups, or both. And really make sure you understand this. When you assign permissions to groups, that automatically gets applied to the members of that group. It's really the whole purpose behind it. Now, Windows and Linux both make use of permissions, but they do it slightly differently. Traditionally speaking, Linux has a simpler permission scheme, and we can see it here, right? You have 3 permissions. You have read, write, or execute. Read permissions means you have the permission to read that file. Let's say this is a text document, right? A flat text document. If you don't have a read permission, you can't even see what's inside of it. Write permission says you have the permissions to make changes to it. I can add a line to it, hit save, and exit out. I'm writing to the file. So I can have read permission without necessarily having write permission. It's technically possible to have write permission and not have read permission, but it's kind of weird. You don't really see that commonly. This third permission is execute. And that means it's not so much a straight text file with information in it, but it's some kind of program. It might be a shell script. It may be an actual binary executable program. If a user or a group is not explicitly granted permission to execute it, they can't run it. Right? Solitaire. If I remove the right to execute Solitaire, no one can run it, hence they can't play it. Now, Windows is along the same lines, but it's a little more comprehensive. Under Windows permissions, you also have the standard read and write permissions, which is means pretty much the same things it does under Linux. You have a hybrid permission called read and execute, which allows you to do just that, read the contents of it and execute it, if it was a batch file, let's say. You have the modify permission, which allows you to change everything about it except for the ownership. Now, ownership is a concept we haven't really explored yet. Every file, every data entity in a system has an owner. Right? So if you log into a system as Bob and you make some files, those files will be owned by you. You'll be the owner. I can go and grant permissions to people to read them, write them, execute them, or modify them, which means change permissions, and they can do everything except change the ownership of that. They can't take it from me. Full control means that has full control over that thing. You can grant permissions out, you can change ownership, you can do whatever you want to it. Full control is all powerful for permissions. This last one down here, special permissions. This is where you have different hybrids of permissions, right? And again, it's out of scope for us. It's actually under the Advanced tab here if you see this button on a Windows system. But you can get very granular in how you apply these permissions, and that's kind of what the idea behind there is. For our purposes, though, really make sure you know our primary ones. Read, write, execute, full control, modify. So, we've set up users, we've set up groups, we've organized our users into our groups, we have data out there in our servers, and we've gone through and diligently applied permissions to those resources. That's great. That's a good job. In fact, that's the type of work that people tend to experience first when they first get into information technology. A lot of people's first jobs are positions where they are doing user support. So they might be creating users, they might be resetting passwords, they're fixing permissions problems, that type of thing. Well, we do all this because there are security threats. Right? If there was no security threat, we wouldn't even have multi-user operating systems. But there's nefarious people out there trying to get in to steal your data, trying to get in to steal your private information, proprietary information, whatever. So they present threats to us. And really, there's 3 primary threats that we need to look at within the scope of our course. One is password cracking. The idea that I can figure out what your password is. Right? I can do this either by cracking it through the use of some type of dictionary cracker, through the use of brute force. Maybe I'll just go through and try every possible password combination until I finally get it right. Next slide, we're going to look more closely at password best practices. But simply guessing the password or breaking the password is certainly a big threat. Another threat actually the next 2 threats aren't technical threats at all. They're human, right? One is called social engineering. You get a phone call, your phone rings. Hey, this is Steve over from IT. I'm doing an audit of all the systems, so I need to go in. I'll need your username and password so I can go in and take care of your stuff. Believe it or not, a lot of people fall for this. And it's really it's no small wonder. As human beings, we want to be friendly. We want to be helpful when people come with us for help or come to us for help. So nefarious types are not above going out and manipulating that. Person walks into into an office. They've got the polo shirt. They got the Dockers on. They got the little laptop briefcase. They look like an IT person. They go up to the receptionist. Go, hey, the boss called me. Came in to do some work on the file server. Can you let me into the server closet and get me the passwords, please? Amazing how often that can work. So organizations need to train their employees. Beware of social engineering. The third is exactly what it looks like: dumpster diving. Right? Throwing away information in the regular trash that could contain things like usernames, passwords, IT policies, internal memos, documentation, anything that someone who's trying to get some idea, network diagrams. There's a good one. Anything that someone's trying to gain access to your environment, they're not above going out and digging through your garbage, trying to see what they could find. Sensitive information, shred it. Don't write it down. Whatever. But be aware that your trash could give you a backdoor into your environment. All right, passwords. There was a time when passwords could be anything. And for the longest time, the most common password on the planet was the word password. Right? It's still way up there. That is what we would call a weak password. Right? We're going to look at examples here of weak passwords and conversely strong passwords. You can set these rules up in modern operating systems called password complexity requirements, where you can say, okay, you have to use a password, and and your password must contain at least 9 characters, must have at least one uppercase character, and must have at least one number in there. That was actually a very common one, like from 10 years ago. And very quickly, the most common password became password 1. Right? Bad. Easily guessed. That's an example of a weak password. Let me in. Boy, that's another easy one. I've been to a lot of training courses, and that was the default password to get into the school machines. Now, these passwords are okay for lab environments. Even in our lab, we use passwords like that. That's fine in academic situations where there's no real data being at risk here. But in the real world, no. Bad. Other examples of weak passwords: names. Names of your pet. Birthdays. Your kid's name. Words that came straight out of the dictionary, because there are dictionary crackers that will go through and just iterate through a dictionary, trying all different words in there as possible passwords. You'd be amazed what people use for passwords. So let's look. What's the difference? What's the opposite of that? Well, how about some strong passwords? Right? Well, the longer the password is, the stronger. So that's one plus. And the strongest password would be like 15 characters long, and just this random mix of upper, lower case, special characters, alphanumeric, and so forth. Good luck remembering that. All right, that's what causes people to write it down and stick it to their ceilings. So there has to be a happy medium here somewhere. Well, here are some examples of what could be stronger passwords. Right? Look at this top one right here, Delta Gamma. I'm replacing my E with a digit 3, and I'm replacing my A with an @ symbol. Or at least my last A with an @ symbol. That's a little easier to remember. It's still not great. It could still be relatively easily guessable, but it's better than password 1. I love my guitar, which actually this one's not that great either, because it forms a phrase that could be guessed. But we have some good elements in here. Replacing letters with special characters, replacing I with the exclamation point, the @ symbol. Caret case, mixing upper and lower cases with no apparent meaning. All right. Remember, passwords are case sensitive, so that's definitely a good thing. I'm not even sure what the third password is trying to spell out, but it's not a bad one, right? So, I mean, it doesn't really map to any dictionary word. It's really not obvious. Assuming you can remember this, it wouldn't be a bad one. Now, the problem with this, especially for administrators, is that we're not limited to a single password. We probably have 6 to 10 to 12 different passwords we've got to remember, and oh, by the way, you're not supposed to write any of them down. And they're supposed to all be different. How do we possibly remember it? You come up with some method for doing it, something along these lines. Something where you replace, I don't know, you replace the letter K with a numeral 7 every single time, let's say. Right? Make use of your caret case. Make use of special characters. Okay, I always replace the letter A with an @ symbol. That type of thing. Now, one thing that's been gaining in popularity in recent years is the idea of the passphrase. And the idea behind this is people have a hard time with these kind of strong passwords, especially regular users. Especially regular users who change their password on a Friday before a 3-day weekend. That following Tuesday, the help desk is alight with people who can't remember what they just changed their passwords to. It happens all the time. Passphrases really break from the mold. They get away from this whole thing of you have to have special characters and upper and lower case and all this other stuff. Except one requirement, that they have to be really long. Right? Your passphrase must be at least 27 characters long, let's say. Remember what I said earlier, the longer a password is, the harder it is to just crack. So a passphrase is something along the lines of all is fair in love and war. And you type that in every time you log in. That can be a very difficult password for someone to break if they were just trying to do a brute force attack. And that wraps us up. Look at that. We covered a lot of ground. So go ahead and make sure you do the reading in the book. Make sure you do any labs that are assigned this week. And I will catch you on the next chapter.